Good morning. This is Sarah Trotty. Happy to be here with you today to talk about the C-STEM Challenge for Sculpture. We're on cycle 4 and we'll begin our design prototype for sculpture. Students will create prototypes of their sea turtle sculpture solution. This is where you should be in your work at this time. Elementary school students will construct an endangered sea turtle sculpture in the form of transportation that improves access to clean water or energy. To make the sculpture, elementary schools will use recycled and reused paper material. Here's an example of a cardboard sculpture. Cardboard is a very sturdy paper that can be used, and you simply need to just cut the cardboard into the shapes that you want, tape and hold them into place until you can glue them, and this provides the basic strong material that you want. And actually you can at the base of these provide ways to allow them to move. Middle school students will construct an endangered sea turtle sculpture in the form of transportation that conserves water and or energy. To make the sculpture, middle schools will use recycled and reused plastic materials. Any plastic material that you can find, such as this example. These are plastic hangers, plastic spoons, plastic wiring, any kind of material that's plastic. Water bottles are great. Anything that you can find that is basically plastic that you don't want to just throw away and on the earth. Now, this is another example of a sculpture using plastic, but let's look at how color is added to the surface. In each of these sculptures, you're to add color using only the material that you use. So paper, students in elementary school will use paper. You can use collage paper to give color to your final product. Middle schoolers will use plastic material. So all the colorful pieces of plastic that you can find can be glued to the surface of your structure that's made of plastic, and this then gives you color. High school students will construct an endangered sea turtle sculpture in the form of transportation that efficiently utilizes clean water and or energy. So in this case, it's not conserving it, but using it efficiently. So to make this sculpture, high schoolers will use recycled and reused aluminum materials. We'll show you an example. Here you see found pieces of metal that are either glued together or wired together to create this sculpture. And of course you'll notice that there's no color used here. The material gets its color from the materials that are found. Each school's endangered turtle sculpture masterpiece must not exceed 4 feet by 4 feet by 4 feet, meaning 4 feet tall, 4 feet wide, or 4 feet in depth. Now, it should not be much smaller than that either, but this is the largest size that you can use. So let's come close to this size that's provided. All sculptures must be accompanied with a typed one-page report and a scaled engineering design of the sculpture masterpiece on 11-inch by 17-inch graph paper. Teens will also use 3D printing design in order to create a C-STEM logo that must be attached to their final endangered sea turtle sculpture. This identifies the work for you. The dimensions of the 3D design must not exceed 3 inches by 3 inches by 3 inches. And you'll learn how to do the printing design with another team. To create surface color for your final sculpture, again, using discarded or found materials in the same medium, you're to remember to look for things that have these colors. Do not use paint or on any of the sculptures, whether it's at the elementary level, middle school level, or high school level. All sculptures must be self-standing and well balanced, and they can demonstrate mobility, or really should demonstrate some mobility. Students should be encouraged to do research on the topics before engaging in the plan of their compositions and in designing the sculptures. So there are some examples of research about clean energy at the beginning here. I won't go to those sources, but let me just go to one of them here. And this source again talks about water energy as a renewable energy source and its importance of us using this energy wisely. Industrial plants that are possible to create this gives us some idea of it. Now, as you're making the sculpture, you want to think of this sculpture itself as maybe even being one of these kinds of generators that are created. Can water move through your sculpture? Of course, we aren't going to show that, but you want to get an example that shows that water is important to the sculpture. Students should also Google search water treatment plants and that technology, and they can visit water areas, and they really ought to look for found objects as a team. So when you're at home or at your grandparents or anyone, ask people to save all the paper goods for you, all the cardboard goods for you, all the plastic goods for you, any pieces of metal if you're in high school, depending on your grade level, so that you can have lots of these materials to assemble the sculpture that you're making. This concludes our this concludes our sculpture discussion. We'll have some moments now to discuss those a little bit later on as we chat live with C-STEM Break.